Hello everyone, in this module we are going to learn scalar objects in NumPy. So in this section we will discuss what is scalar object. Later we will discuss attributes and methods of array scalars. So basically array scalars have the same attributes and methods as arrays and live in a hierarchy of scalar types. So they can be easily classified based on their type object. However, because array scalars are immutable attributes that change the properties of the objects. So array scalars can be detected using the hierarchy of data types. For example, isInstance method will always return true if val is an array scalar object. Alternatively, what kind of array scalar is present can be determined using other members of the data type hierarchy. Now let us discuss the attributes and methods of array scalar. So these are the attributes and methods of array scalars which we are going to use in a NumPy array. So based on these functions we are going to discuss some example related on attributes and methods of array scalar. So first we are going to discuss the ndim attribute. So basically this attribute will help the user to find the number of dimension of an array. For example, suppose we have a two-dimensional array and we want to know the dimension of this array. To check this we will use the ndim attribute along with the array name and it will return the 2 because of this two-dimensional array. So our next function is item size function. So basically this attribute will help the user to know the length of each value of an array in bytes, and this method does not take any parameter and it will return the length of an array. For example, suppose we have an array that contains only integer values and this attribute will return 8-bit of memory. So in this example we have created an array by using the np.array function, and within this function we have assigned the integer values as an argument, and along with that we have mentioned the dtype parameter and assigned np.int64 val data type. So after using the ndarray.itemSize function, where in this example ndarray is a product id, so after executing this code the output comes the item size 8 byte. Now our next function is ndarray.size. So basically this attribute is used to calculate the total number of values which are present in an array. It is equivalent to the product of the NumPy array's dimension. Suppose you have a two-dimensional array we have mentioned in the example, and if you want to check the size of this array, then you can easily use the ndarray.size attribute. So this attribute will always return the size of the array. So after executing this code, the array size is 6 because number of elements in input array is 6. So our next attribute is NumPy shape. Suppose if you want to check the shape of an array, and by using the np.shape function you can easily get the shape of a NumPy array. So in the case of a one-dimensional array, they do not have mentioned the columns and rows, so we can easily return a single value tuple. So after using this function we have assigned the input array as an argument. So after executing this code it will return the shape of the given array, and it is 7 because it is a one-dimensional array, so it is 7. If it is a two-dimensional array, then it will show the number of rows and the column. Now our next attribute is dtype. So basically this attribute is used to create data type objects. Suppose you have a one-dimensional array and it contains only numeric integer value, so it defines an integer data type. So in this example, first we have imported the NumPy library, and after that we have used the np.dtype attribute. Within this we have assigned the np.int64. So after executing this code, it displays the data type of the array scalar, that is int64. So our next function is numpy.real. So basically this method is used to get the real part from the complex number which we have passed as an argument in the input array. And this function takes only one parameter, that is val, and it specifies the input array value. So in this example, first we have created an array by using the np.array function, and within this function we have assigned the complex number. As you can see that as an argument we have mentioned the complex number. So after using the np.real function, and we have assigned the input array which is sample number. After executing this code, the output comes the real part from complex number, that is 682. And if you want to extract the imaginary part from an input array, then you can easily use np.img function. So basically in this example we have created an array by using np.array function, and within this function we have assigned the complex number as an argument in it. So we have to find the imaginary part for input array. So with this we have used the np.img function, and within this function we have assigned the input array as an argument. So after executing this code, it will extract the imaginary part from complex number. So with this we have completed the scalar objects in NumPy.